Greetings, class. I'm still in Chapter 7, Section 3, looking at problems from the section exercises on page 381 of your text. These are somewhat similar to the homework problems you see in my stat lab. So I'm going to look at number 11. We're going to use technology to test a claim about the population mean, mu, on the level of significance alpha. It says assume the population is normally distributed, and that's an extremely important piece of information because even though we do not know the population standard deviation, we must know that the population is normally distributed in order to do a test to determine the t-test statistic, whether we reject or accept the null hypothesis. So let's look at our claim. Our claim is that the population mean is equal to 15. Now, since it has an equal sign, I'm going to go ahead and type this in. H sub O would be equal to, H sub O would be that the mean, and I don't have the mu symbol over here, but that the mean would be equal to 15. Now, our alternative hypothesis, H sub A, would be that the mean is not equal to 15. Again, I don't have the symbols in StatCrunch to type this out, but I'm going to go ahead and put this in here. So these are our null and alternative hypothesis. It's important to note that this was the claim, that the null hypothesis was the claim. Now, alpha is 0.01. So we can find t sub 0 or t sub O. It's actually the critical value like we saw in the questions 9 and 10. And I have to use the calculators, in this case a t calculator. Since n is 36, my degrees of freedom would be 35. Alpha is 0.01. Since it's not equal, that means that it is a two-tailed, so that means I have to use the between, and I have to take 1 minus alpha, or 0.99, for my area to find the critical values. So I have to use 1 minus alpha, in this case 1 minus 0.01, which is 0.99, for my test. Now remember that this is the only one, when we use the between, the two-tailed, where my rejection regions are actually here on the left and on the right. So and they were t sub O's, and I apologize that in the last one I had used it as I told you t sub critical, but the book uses t sub O. So in this case we have a negative 2.724. I'm just going to use 3 decimal places in this one, and a positive 2.724. My stat lab will tell you how many decimal places to keep. In this case, I rounded to the nearest thousandth. So those are your critical values. Now your rejection region is when your t-test statistic, the one you get from running the t-stat, is less than a negative 2.724, or when it's greater than a positive 2.724. So that's when t is less than a negative 2.724, or when t is greater than a positive 2.724. And I got all of that from the t calculator. So in order to find your rejection region, you have to use the t calculator. Now, to find your test statistic, you go back to stat, but this time you do a t-stat, one sample with summary, and you notice that they ask you to find or to provide the sample mean, the sample standard deviation, and the sample size. And those things were all given to us. The sample mean was 13.9. The sample standard deviation, S, was 3.23. And the sample size, N, was 36. Now, this is a hypothesis test. So we do need to see the actual, it said the claim was that mu was equal to 15, so we put equal to 15, and then I have to do the complement for H sub A, and the complement of equal would be not equal. And I'm going to store this in the data table and compute. So when we do that, you will see that the t statistic is negative 2.043 or negative 2.043. So I'm going to put this over here. So the test statistic was equal to a negative 2.043. Let's go back and look at that. I probably should have just copied and pasted, which I could have. Control C. And then I'm going to come back over here and down. I'll put it right below there. Control V. So negative 2.043 to 2 decimal places. So when you look back at that T calculator and you compare negative 2.043 to negative 2.723, okay, so here's negative 2. Negative 2.04 is just barely to the left of that, and negative 2.724 is way over here. So we are not in the rejection region. We're actually in this nice region here where we would fail to reject. So you might want to talk about the fact that T equal negative 2.043 is not less than the critical value, or T sub 0, T equal negative 2.724, we fail to reject H sub O. So we fail to reject. Now, since the null hypothesis is our claim, and we fail to reject that claim, we actually can say that there is not enough evidence at the 1% level of significance to reject the claim. So there, I apologize, I'm misspelling here. That's twice, I'm so sorry. There is not enough evidence at the 1%. Remember, alpha was 0.01, that's 1% level of significance to reject the claim. Now, you might be wondering where I'm getting the wording for this interpretation or decision for about how I'm interpreting the t-test statistic in comparison to the rejection region. And I'm going to show you the page in your book that allows us to see that. So I want to bring your attention to page 356, where we talk about claims and decisions. In our case, the claim was H sub O, and we failed to reject H sub O. So as a result, there is not enough evidence to reject the claim. That's your decision. So if you're having trouble deciding how to word these particular decision rules can help you in your wording. And that's on page 356 of your e-text. Greetings, class. I thought it might be good to look at number 15, where we also use the rejection region to determine whether we will reject or fail to reject. So it says a used car dealer says that the mean price of a 3-year-old sports utility vehicle in good condition, and the key word here is $20,000. So I know that the claim is that the mean equals $20,000. And since it's an equality statement, I know that's H sub O. Now, the alternative hypothesis is that the mean would not be equal. The mean is not equal 20,000. Now what this means is that what this results is that I know now that I'm going to have a two-tailed test, much like number 11 that we just finished. Now the first thing it says, you suspect that the claim is incorrect and find that a random sample of 22 similar vehicles, so n equals 22, little n, and has a mean price, so that is your sample mean is equal to 20640, and the sample standard deviation S is $1,990. Is there enough evidence to reject the claim at alpha equal 0.05? Now remember, since this is two-tailed, that in StatCrunch, I'm going to need to use 1 minus 0.05, which is the 0.95 area that I will look for. So I'm going to pull up StatCrunch and open a new table and use the information I have in Word. So I'll pull that over so we can look at that. And the first thing we have to do is find our rejection region. So I go to the calculators, the T calculator. My N is 22, so I have a 21 degrees of freedom. 0.95 is the area that I'm looking at, but it needs to be a between. I'm so sorry. It needs to be for the between. 0.95. And you can see that the values are between negative 2.0796 and 2.0796. That is where we fail to reject. So anything, the rejection region is going to be if your test statistic is less than a negative 2.0796, or if your test statistic comes out being greater than a positive 2.0796. So let's run the test. We're going to do a t-stat, one sample with summary. The sample mean that they gave us from the 22 cars was 20,640. The sample standard deviation was 1,990. Our sample size was 22, and we're testing a mean of 20,000. And when we hit compute, it tells us that the t-stat is 1.0 508. So our critical value, or our test statistic, I'm so